feels a little bit banal to be talking about security after this very important topic, but I'm going to give it a try. How to build a fortress with the security of a tent is meant to be a bit provocative. I'm going to put some blame on single-page applications, mobile applications, various stuff today, but I'll walk you through it, so bear with me. My name is Jacob Ideskog. I'm the CTO at Curity. I work with identity daily, mostly OAuth, OpenID Connect, adjacent standards to that. We're pretty geeky at Curity. We like what we do. Java programmer, tech nerds, all of us in general. It's a fun company. I like being there. But today, in order to talk about security, we need to talk about the onion. I think a lot of you know what I mean when I talk about the onion, because the onion has layers. Security is something where we need to think about defense in depth. We need to add many layers, because we can't rely on a single mechanism at any point to be secure. There could be vulnerabilities showing up, there could be mistakes being made here and there, or just the fact that we can't think of all the attack vectors that attackers can think of. So we need to add many of these layers. So the onion is a great example, and it's good to keep in mind. So I want to start a bit historically on how we're building our API fortresses. Because let's face it, we've been at this for a while now. I mean, Nordic APIs, we started in 2013, and that journey over these last 9, 10, 11 years have, a lot of you have moved not only your API story, but your API security story forward as well. So you built the fortress to some extent. This is supposed to be a firewall, by the way. I don't know what happened when asking for one of those pictures. We started off with having these services internally, 2012, that time period, 2010, and even way before that, of course, with the SOA and everything. We secured these. It was a bit simpler back then because we could put computer security in place. We had networks separating various services from each other. We had policies to govern those networks. We put a big firewall around, and after that, it's all good. If you needed to connect to that, you added a VPN, and then you got through. So we had pretty good control. And then around the shift 2010, 11, 12, the mobile devices started showing up more with apps that we could build on our own. We wanted to have access, thus the API revolution, at least in my opinion. That was a big trigger. And we realized APIs are great because we can do a lot of stuff with them. All the applications can use the same services the same way. So this triggered a big shift. But obviously, this arrow is piercing through all these layers, and that's not going to work. So we had to add more stuff to our fortress in order to make this work. So we got API gateways or application firewalls, reverse proxies, this type of function, which was the port of entry. So if you're going to go into the network, you have to go through the API gateway, and it will forward you to the right service, to the right API. We'll still keep everything else. We're just adding more. Which begged, the important question of who should then access this, obviously. And there were standards in place and starting to be formed. 2012, OAuth came about, and it started talking about tokens. We can use tokens to communicate identity when we talk to APIs. And tokens are great because they contain enough information for us to both know who is the user, who's the caller of this request, but also what's it allowed to do to some extent. What's the access that we're trying to allow with this token? How long is this valid for? There's a lot of important information in a token. So we attach this to the requests, and we let this flow through our system, goes through the gateway forwards it after checking that it's fine. And now we can start doing stuff like building a zero trust architecture. Now we can deal with workload identities. There's a lot of stuff now we can add on here using this. So OAuth 2, I'm sure you're all using it, and if you're not, you're probably looking at it, because it's really the only security standard there for identity for APIs. But it lets us limit the access to APIs based on the user and the application together. And it provides this identity plane, if you will, on top of the data plane. So it kind of adds all this information, which is super useful. But what we're really doing with OAuth is we're building a token-based architecture. That's the abstract notion of things. Because we're using tokens to make sure we have identity flowing, we know who can access what at all times. And tokens turns out to be a great tool for this. And when thinking about tokens, if you listen to Judith's talk before, she mentioned some of this. There's a few things you should know. And I mean, all of us who have ever seen or been near a system that uses tokens has probably heard of the JSON Web Token, which is, the poster child of tokens and OAuth and all of that. But it's not super interesting with JSON Web Tokens because it's a format. It's how we encode stuff and how we ship stuff off to another system and how they interpret it. That's, details. The interesting part about tokens is how can you use them? And there's really just two ways. We have what's called the bearer token. I'm not going to get super technical here, but we have a bearer token, which is like cash. If you pick it up, you can use it. So if you print that in a log, someone grabs that, they can use that. That's a bearer token. That's the most common token used in OAuth. It's very easy to use, very convenient, but that's a side effect. The other type of token has more names. We can call it a holder of key or a proof of possession token or a sender constraint token. It can only be used if you can prove that you're the rightful sender of the token. So if it's issued to you, only you can use it later on. And you typically prove this by some other mechanism, mutual-TLS or some other key that you prove that you have. So these are the two. That was a side note. But of course, we add these to our fortress, especially if we're doing advanced workload identity and workload security and all of that. So we're having these tokens coming in, but typically they're bearers on the outside, because that's how we used to do it. We have the gateway. Now it translates it into one of these holder of key or proof of possession tokens and sends it on to the API. And it needs to call another API, so it translates it and exchanges it for another and sends it on. You see, it gets pretty complex, but this is probably where some of you are. This is a legitimate fortress. It's super secure from an API perspective. We have auditability. We have a lot of stuff here. So we built a pretty solid fortress when it comes to API security. We started with some computer security. We added network policies. We added firewalls. This is a bit messed up, the animation, I guess, but never mind. The layer 7 firewalls, application firewalls. We added token-based architecture and proof of possession tokens. You reach nirvana on computer security or API security. And that's good, because if you look at what Gartner just said, current data indicates that an API breach leads to 10 times more data leak than a regular security breach. That should scare all of us, because that's pretty bad. So if you're not already at that fortress level, you should think about that. But that's not what we're going to talk about. Because the real question now is, who comes knocking at the door on this fortress? We are building applications, obviously. Single-page applications, classic websites, mobile applications, server-side applications, other APIs calling your API. We want all of these to use it. And they're built by your organization. They're built by other organizations, third parties, could be any. So we have a lot of various entities knocking at the door of this castle. Which brings me to the real topic, tenants. Because what we're doing, if we're not thinking about these integrations and applications that are out there, we're essentially handing out part of the responsibility of the security to the tenants. And whatever we did in the fortress doesn't matter. And I'm going to talk about 3 in particular: integrations with other systems, web apps, and mobile apps. And I'm also going to show some tools that we can use to turn these tenants into fortresses as well. So let's start with the first tent, integrations. So you built whatever API. turns out it's really useful. So someone, maybe at your organization or another organization, realized, hey, we can connect this to our CRM, because then we can pull in some data there, and that's valuable, that's useful, saves us time and money. So it gets pulled in there, and then someone else realizes, oh yeah, we can pull it into our finance system, and then maybe a third party starts using it, and all of a sudden there's a sprawl of usage for that API. And that's great, that's what we want with the API. But then you start seeing things like this, where token theft is being mentioned in various places. These are particular to GitHub and Microsoft and so on, but essentially what they're saying is credentials have been stolen, tokens, from other systems than your own to gain access to you. This is a new type of supply chain attacks. If you think about the SolarWinds attack, this is not it. This is more shadow IT stuff, because that integration to the CRM system, that resulted in a token ending up there, and someone could go there, take that token, and they don't even have to knock on the door to your fortress, they have the key. They can just go right in. So your API is really part of this new supply chain, and that can be internal, because as you realize, many of the systems you consider internal are not internal. You buy cloud services, you start integrating them with the stuff, and you probably don't necessarily know that. That's why it's also part of a bit of a shadow IT structure. So obviously, it's much easier for Mr. Attacker to go and find some mistake done in some other system, or someone published something in a source repository, and all of a sudden, they could get tokens, and they could just walk right in. And the real question, of course, is who gets the blame? You know, the CRM got hacked. They should get the blame. But in the end of the day, whose data was exposed? It was your data. It was your stuff. So I don't think the European Union will care so much if there's a GDPR breach and you're going to say, but it was the CRM. I mean, it's your leak. It's your data. You're going to be in the news. So it's super important that you take care of this type of sprawl usage. So what do you do? Because we can't just tell everybody else that you need to be careful with these integrations. You need to do it right. I mean, we probably already do, right? We need to have protocols in place. We need to have enforcements in place to make sure that in every single use case, you cannot make mistakes. It's not allowed. So in this particular case, turns out there's a great extension to OAuth called FAPI, or Financial Grade APIs, or we sometimes call it Fortified API Security. And in FAPI, there's a lot of stuff that you can add to your OAuth flows or your integrations to other parties that enhance security. And one of them is this one I mentioned before, but I called it proof of possession token. They're also called sender constraint tokens. If you do just switch to that for these type of integrations, it's not enough anymore to steal the credential or the key, or the token. You will also have to try to figure out how to steal the keys, the private keys that the other organization have. And what's interesting about that, I'm not going to go into details, but keys are typically provisioned in a different way than credentials and tokens. They could be in certificates, which are handled and injected into the workload as you're starting them. So they're not, even if you find stuff in source, checked in, the keys are usually not there. They're elsewhere. So it's a very small update. It does complicate integrations a bit, because you have to use a different mechanism when communicating with the API. But it completely changes the game for how susceptible you are to these supply chain attacks. So that was tent 1. Let's go into tent 2, which I named my talk after as well. Web apps, or more in particular, single-page applications. Most of you, probably all of you, know what these are. In case someone doesn't, they don't really have a backend. We render everything in the browser. All the logic is in the browser, and we try to avoid, this tight coupling with a backend that has logic. So a single page application is typically loaded from a CDN and has a lot of advantages when you want to build application-style website. And they often, of course, use APIs heavily. If you have to, they probably use cores to reach them across domains. And since you're doing APIs, and since you have this fortress, they're going to have to do OAuth in the browser. And up until recently, the only way to do OAuth in the browser was to treat OAuth as any other API from the browser. You do cores, run the flow in the browser, get the tokens in, and then call the APIs using those tokens directly from the browser. Which begs the question, where do you store those tokens then? And there's been various answers. Well, just put them in local storage, put them in session store. No, try to hide them, put them as a service worker somewhere. Try to be clever, put them in memory. There's a lot of ideas back and forth. Because ultimately, whatever we do in this type of application and whatever mechanisms we're trying to imply or apply to protect these tokens, there's something we should know. All web applications, but single-page applications in particular, since they're doing so much in the browser, are very susceptible to what's called cross-site scripting. Cross-site scripting is using the fact that we're running JavaScript in the browser, the application is built in JavaScript, and the attacker just needs to find a way to put more JavaScript there. And if you do put more JavaScript in the browser, there's a lot of interesting stuff you can do. So I took this example from Dr. Philip Durick, very clever guy. Here we can see that with 2 lines of code, creating an image tag, and then setting the source of that image tag to some malicious URL, data equals JSON stringify local storage. We just exported the entire local storage to some malicious site somewhere. And if we had our tokens in there, they're gone. And you won't know, because when they use those tokens, there's no way you could know where they come from. You can't really tell from the server side. So they could be attacking you, and you won't know. And there are a few ways to get attacked like this. One way is what's called blind submission, that someone enters some code in a form, and then later when you view that form, it executes. It's blind because obviously you don't know really when that view is happening and what's on that site, but it could work. Reflected user input, that's pretty common, that something on your site is not safe enough, so it reflects some input, like a query parameter or something else, and writes it back to the screen, which means you could potentially load scripts that way. Or supply chains. The real supply chains, your dependencies. They could also be compromised. And of course, we keep track of that. We have scanners, we have tools. I created a new React plus Next.js project. Turns out I got 360 dependencies without a single line of code. So there's quite a lot to manage just out of the box when doing these. And it very easily gets up in the thousands. So, I mean, the chances of one of them being vulnerable or susceptible to some sort of cross-site scripting attack, or 2 or 3 of them combined, opening up a vector, super possible all the time. You should count on it. Which also leads us to this reminder, because cross-site scripting is dangerous, not because you only get, the attacker runs code, but because the attacker runs code the same way you run code. So if you can get a token, the attacker can get a token. If you can refresh something, they can refresh something. They can be persistent. They can add hooks and event listeners and wait for the user to leave the browser and then start using the tokens later on. I mean, all bets are off. They can do anything. So there's nothing protecting you once that happens. So really, the browser is a hostile environment, and we need to figure out how to solve that. And I think the only solution to this problem, when we want to do OAuth, and we want to have a single-page application, and we want to make sure our fortress is secure, is to simply remove the tokens from the browser. They shouldn't be there in the first place. Anything that the JavaScript can access shouldn't have the tokens. So there's a pattern that's come up recently called the token handler pattern, or it's also called the backend for frontend by IETF and others. The token handler pattern is very interesting because it adds a super small backend, a generic backend, call it a BFF. And the BFF, the backend for frontend, it's the same for all single-page applications in the entire world. You can take one and deploy it as many times as you want. So no tight coupling really on code. But what it does is it takes over the responsibility for communicating with the OAuth server and communicating with the API. It translates it turns this token session into a regular cookie session and translates that into tokens when it's time to call the API or when it's time to refresh. There's a lot more details on that, of course. It's completely stateless. It doesn't need a backend. It does everything using cookies. Because the nice thing is, cookies have been around forever. Cookies aren't incredibly secure, but they're way more secure than what we had before. So if we simply move back into the old paradigm of how we do sessions on the web, we encrypt tokens in the cookies, we make sure only the right party can decrypt them, and we completely remove tokens from the JavaScript access, then we're actually in a pretty good state. Then we're on par with, as good as you can get on the web today. And because browsers doesn't let JavaScript access cookies if you do it rightly. So that's a good pattern, and you should be using it if you're doing single-page applications. So that's 2 tenths. One more. Mobile applications. So it turns out that writing a mobile application is hard. If you want to build a secure mobile application, it doesn't happen on its own. So the operating system provides you with a lot of tools to make a secure application. But if you don't use them, you're not secure. Which is why we very often in the OAuth community talk about mobile applications as public clients. Because you can't really compile in a secret there. Like if you do, someone can decompile it and find it. So you can't trust it with secrets from the bootstrapping scenario. And there's a surprising number of attack vectors to consider when building mobile applications. And if you're not thinking about them, this is a very likely scenario. Because what happens then is the mobile application needs to access your fortress. So it says, hey, I'm client 1, can I get a token? But this is a public client. It can't really prove that it's client 1 because we couldn't give it a secret. So the fortress says, sure, I've authenticated the user for you, here's a token. But if you didn't add any of the security mechanisms that you should have added on top of this thing, this can happen. A phishing app can be built and it can do the same thing. Hey, I'm client 1, can I get a token? Sure, you're client 1. Because I don't know, I authenticated the user. Of course, we're not doing that. But if you do, that's the end of the story for that user. They got pawned. So we definitely can't make it up to the user to be sure they're not being phished. It's our problem. We need to solve it. We need to add all these layers again. But turns out also in mobile, the solution is we need to get from this public version of a client to something that is confidential, something that we think can keep secrets. We can turn it into sort of a fortress on its own. And for a number of years now, there has been a mechanism that can help us with this in the mobile environments, both iOS and in Android. It's called attestation. Attestation is using a hardware chip on the phone, which you can use to generate keys, but you can also use it to get proof about the current state of the application on the phone. So you can ask the phone and say, hey, I need to attest that I'm this app, and I need to send that and prove that to someone. And then the receiver of that can verify, yes, this is actually proof from that hardware trip signed all the way up to Apple that this is the correct app, the device is not rooted, there are a lot of good information in there. So now I believe that you are the correct application. And that means all of a sudden we can now trust the app with confidential information because it could generate a key and it could say, hey, I'm this app, here's my public key because I just created a key pair here. And then we can say, great, we understand that you are the one, we're going to trust you. Now we can start sharing information in a more confidential way. So we can bootstrap the whole confidentiality issue by using attestation. Super powerful. It's already built in. We just need to use it. So in this scenario, hey, I'm client one, please give me a token. Here's proof. The result is, yes, indeed, you are client one. Whereas if the attacker were to do the same, they couldn't, because they can't attest that they are client one. They are something else. So the operating system will not allow that. And it's not bypassable, because it's done in hardware. Very nice. So we're turning these tents into fortresses. And that's really important, because otherwise we're kind of doing all this building for nothing. That major breach could be waiting for us if we're not thinking about these integrations. And when I say thinking about them, we need to use the tools to force this. And there's tools for a lot of these cases. I mentioned 3. There's a lot more, obviously, to think about. I'm scaring you a little bit. Yes, that's intentional, because it's serious. We're seeing fraud going up. It's happening more phishing, more fraud, more attempts to do account takeovers, all these things. We need to play our part with our systems. The tools I mentioned today was the financial grade API addition to OAuth and OpenID Connect, the token handler pattern or the backend for frontend, and the mobile attestation stuff. So keep in mind that API breaches are super expensive. You probably know it, but they're more expensive than your regular breach. So you need to fortify not only your API infrastructure, but also the integrations. That's super important. And you do that by forcing this integration to use the correct protocol. The protocol is the way to force it, because if you demand you have to use this mechanism or that mechanism, they can't circumvent it. And you can trust that that third party is as secure, at least, as you want it to be. Thank you.